Video, I'm going to go over 1, 3, 7, 10, 12, and I will go over the exceeding one question. I'm not going to go over the other two for that. Normally I don't do the exceeding questions, but I will go through the exceeding one. A couple people were asking for it. Okay, so for this one, number one, I'm just going to write it here. So we have x over 6 minus 11 is equal to 9. So remember, when we're solving, we're doing our PEMDAS in reverse. So what is happening to our variable? Well, I see minus 11, so it's subtraction. And then remember, the fraction means division. So those are the two that I need to get rid of. So that means I need to get rid of subtraction first. The inverse of subtraction is addition, so I'm going to add 11 to both sides. So x over 6 is equal to 20. And then my last one I'm doing is division. Well, to get rid of division, we multiply. So we multiply each one by 6. They cancel out, so x isn't equal to 120. And we learned a different method now when we have fractions. If we wanted to get rid of that, in this case we could get rid of our fraction to begin with. And we see that the only fraction we have is 6. So if I multiply everything by 6, well, when I do 6 times x over 6, it's going to cancel and just give me x. 6 times 11 is minus 66. And 6 times 9 is then going to give me 54. And now by doing that, as long as we multiplied everything by the 6, as we showed 1 plus 2 is equal to 3, and if we multiply everything by the same number, let's do by 5 for this one, 5 plus 10 is equal to 15, it still gives us a true statement, as long as if everything gets multiplied. So now I got rid of my fraction, and I can add over the 66, and 54 plus 66 is then going to give me 120 as well. So it doesn't matter which method you choose, but since we did learn this one, maybe that's the one that you wanted to do first. It doesn't really matter, but we can always just go back to the get rid of our PEMDAS in reverse order. All right, so for number 13, we have 14 plus 5w over 3 is equal to 13. So we can think about this 13 as a fraction and put it over 1. And when we have two fractions that are equal to each other, we know that the cross multiples are equal. So we can go ahead and multiply this 14 times 5 or plus 5w times 1, or just rewrite it as 14 plus 5w. And then we can go ahead and multiply this 3 and 13, which we then know is going to be 39. So 14 plus 5w is equal to 39. You can think about it like that, or this 14 plus 5w over 3 is equal to 13. Well, since the whole thing is being written over 3, this is actually considered a grouping. If we were to know what w is and plug it in, we would have to do this first. So that's considered a grouping, or the p in our PEMDAS. So then we would actually, when we're doing this, the division over 3 is what we would get rid of first, which would then be by multiplying each side by 3, which is essentially what we just did when we did that cross multiplying too. All right, so it's all the same thing, just your own preference of how you want to visualize it. But from here now, we know we have our PEMDAS in reverse. So we have the addition, it's positive 14, and we have the multiplying, 5w. So to get rid of addition, we will subtract 14, so 5w is equal to 25. Then we're going to divide each side by 5, so w is then equal to 5. All right, so for this next one, when we have two fractions equal to each other, we know that they're proportions. And we learn that through proportions, we multiply our numerator, one numerator with the opposite denominator, so it becomes x times 8, and then it's the other numerator with the opposite denominator is equal to 3 times 2. So 8x is equal to 6. We divide each side by 8. So x is then equal to 6 over 8, or we reduce that to x is then equal to 3 over 4. All right, so for number 10, we have 3x over 4 minus 5 over 12 is equal to 1 over 6. So you don't have to get rid of your fractions like I'm going to show you now. You guys are all able to use a calculator, so you guys can just go ahead and add over the fraction and then set up a proportion and solve that way. But we learned that we can get rid of fractions by looking at our least common multiple. So I'm going to take my smallest number and write out my multiples. 4, 8. Neither 12 or 6 go into it. 12. Well, 12 goes into 12 and so does 6. So I know that's my least common multiple will be 12. So if I multiply every single number by 12, I know I'm going to get rid of all of my fractions because every single one of these numbers can divide into 12. 4 goes into 12, 12 goes into 12, and 6 goes into 12. So 4 goes into 12 3 times. So when I multiply this, it becomes 12 times 3 over 4. Well, 4 goes into 12 3 times. So I'm left with 3 times 3, or 9x. When I multiply 12 here, well, the 12s are just going to cancel out, so I'm left with minus 5. is equal to, and when I multiply here, it becomes 12 times 1/6, which is the same as 12 divided by 6, or 2. And now from here, I'm left with a regular basic problem that we should all know how to solve. So I add over the 5, add over the 5, so 9x is equal to 7, divide by 9, x is equal to 7/9. All right, for this next one, same thing as we did for number 7. These are two fractions that are equal to each other, so they're proportions. So we will cross multiply. The only difference is for this one, we have what is called a binomial in both of our numerators. So we have to remember when we write that is to write it in parentheses. You notice I even wrote it in parentheses when it was just x and 8 and 3 and 2s because it's about building good habits. By putting the parentheses, you're reminding yourself everything needs to be multiplied by that. So then when we cross multiply here, it becomes 8 times 6x minus 15. And now we just need to remember to distribute this in. So it becomes 48x minus 120 is equal to 48x. And this would then be minus what? 180 plus 40, so minus 120. So something should jump out at you here now. But we're going to subtract over 48x. I like to move mine to the left, so when I do to one side, I have to do to the other. And they cancel out. So when my x's cancel out, I look at the value, or the question, and I say, okay, negative 120 is equal to negative 120. That is a true statement. So that means that it is all real numbers. Is our answer. You can write it out. You can write the symbol, however you want to show it. All right, this last one, it's really not necessarily the hardest thing. It's just that you just have to take your time. There's just a lot going on. It's everything all in one. So I know that parentheses mean to multiply. So I'm going to distribute this 6 in. So we get 18 minus 12x. And remember, when there's no number written there, it's understood to be minus 1. So I'm going to go ahead and distribute this in. So it becomes minus 4x minus 5. That's where a lot of people make their mistake, is they don't distribute that minus 1 into that second number. So now we have there, and I'm going to distribute this 12 in, so it becomes 12x plus 48, and then we still had the original minus 6x plus 17 left over. Then from here, I'm going to just combine my like terms on both sides, so we have negative 12x minus 4x plus 2x. So that gives me negative 14x. So I have negative 14x, and then I have 18 minus 5, which is then 13, minus 8, which is then going to be 5. So we have negative 14x plus 5 is equal to, and then on the other side, we have 12x minus 6x, so it's going to give me 6x. And then the last one we have is 48 plus 17, which is then going to give me 65, so plus 65. And then I'm going to go ahead and subtract over my 6x to move all my variables to the one side. So we get negative 20x. And then I'm going to go ahead and move this 5 to the other side, which is then equal to 60. Divide each side by negative 20. And x is equal to negative 3. All right, that is it for this video.